Hello. This video will demonstrate how to factor the difference of squares. So before we actually factor the difference of squares, let's look at what it means. So first of all, I have squares. I have two squares. As you can see, my green square has dimensions 10 by 10, 10 meters by 10 meters, 10 centimeters by 10 centimeters, whatever it happens to be. My yellow square is a 3 by 3 square. So what do I mean by the difference of squares? Remember that difference means subtraction. So suppose this is a field or an area of land, and I want to take away this piece of the green. So after I subtract the big square, the little square from the big square, what I have left is this green area here. All right? In other words, the difference of squares really is the difference of the areas of those two squares. So if I think about that, right, the area of the green square is base times height, and that will give me 100 square units. The area of my little square, right, is 3 times 3, or 9 square units. So when I take away the little square from the big square, what's the difference? What is the area that I am left with? As you can see, the area that's left over is going to be 100 minus 9, or 91 square units. So the concept is not very difficult, but it's very important that you understand this as we proceed. So let's try to find 91 square units in a different way. Again, this should look familiar. The green area here is what is left when I remove the yellow square from the big green square. So what I can think about, right? This part here is part of the green square, and we can see that the height is 3, and this length here is 10 minus 3, right? The whole piece being 10, the little piece being 3, so this is 10 minus 3. Okay? Now, I'm going to play around with this, and what I'm going to do is I'm going to duplicate it. Put that back over here. What I'm going to do is rotate this and move it here. You're going to see why I'm doing that in just a minute. But again, all I did is I took this green part here, the red rectangle, I rotated it and just moved it with this part here. Why did I do that? By rotating and moving that smaller rectangle, I've created this white rectangle which has the exact same area as this piece here. All right? Remember, what was left over, the green part, was this. All right? And all I've done, all right, is taken this piece down here, removed it, rotated it, put it here, and now I have this rectangle. All right, and so let's see if I still get 91. All right, I can see here that the length is 10 plus 3, which is 13. The height here is 10 minus 3, which is 7. Let's see, the area is base times height. 13 times 7 is 91. Another way to get 91 square units here. The important thing to remember, and a pattern that we're going to see, is we have 10 plus 3 and 10 minus 3. So keep that in mind as we proceed. Before we actually practice factoring the difference of squares, there are a few things that you need to be aware of. What are the perfect squares? Some of them you know. Hopefully you know up to 10, but let's go through them. And what do we mean by a perfect square? The first one is the easiest. 1, right? And we have our factors, 1 times 1. Why do we say square? Because if I have a square, that's 1 by 1. The area is 1 square unit. So this number actually refers to an area. Similarly, 4 is a perfect square. Why? Because if I make a 2 by 2 square, my area will be 4. I hope you get the idea there. You should commit to memory at least the first 20 perfect squares. All right? 1, 4, 9, 16, 25, 36, 49, 64, 81, and so on. What I do here, again, 144, 12 times 12, not so bad. I think a lot of you can do that in your head. 169 and 196. What I do is, how to remember that is, you have 69 here, and then just reverse the digits for 96. Again, if you can get up to 20 perfect squares, that would help you very, very much. So here is our formula to factor the difference of squares. If I have a squared and I have a smaller square, that is dimensions b by b squared, and I take the difference of those two squares, the area, or what is left, you can get by a plus b times a minus b. So if we go back to our previous example, I had a big square that was 10 by 10. I subtracted a smaller square, 3 by 3. To get what is left, I can say a plus b, 10 plus 3, multiplied by 10 minus 3, a minus b. All right, let's practice. So let's look at a few examples here. Example 1. I want to factor 4x squared minus 25y squared. Maybe this is the difference of squares. Maybe it's not. So as I said, it's very important to remember these perfect squares. I can see that 4 is a perfect square and 25 is a perfect square. So I've got a 4 and a 25. Here's x squared, here's y squared. One way to think about this is to think about if I can get the difference of squares. So maybe if we can rewrite this as something squared minus something squared, it will help us. Again, what number squared gives me 4? 2. X squared, right? X squared, no problem. Minus, minus, right? What number squared gives me 25? 5. And I have y squared. Using our formula, what we have is this piece plus 2x plus 5y multiplied by 2x minus 5y. And what we have just done, we have, whoa, sorry about that. What we have just done is factored 4x squared minus 25y squared. Let's do another example. All right, 144d squared minus 1. Maybe, again, this is the difference of squares. Maybe it's not. I don't know. But what we can do is see if we can rewrite this expression into something squared minus something squared. Again, hopefully you remember 144 is a perfect square, 12 times 12, right? So that helps us. That's 12d squared. 12 squared, 144. d squared, d squared. What about 1? Right? Don't forget about 1. 1 is just plain old 1 squared. So when we use our formula, that says 12d plus 1 times 12d minus 1. Some of you may be asking, does it matter if I do this, 12d minus 1 times 12d plus 1? Both of these are exactly the same. Okay, now we're going to try a few more problems that are a little more difficult. So let's look at 27g cubed minus 3g. And we're looking at this 3. Maybe this is not a perfect square, because if I look at my table, right, 3 is not a perfect square, 27 is not a perfect square. So what do? Maybe we can't do anything. But remember that we can factor some things. All right? We can break this up. This is 3 times 9, and 9 is 3 times 3. Remember, g cubed is g times g times g. And this is 3g. And so remember what we were doing, right? This is common. This is common. We have a g that's common. We take out our 3g, and what are we left with? 9g squared minus, right? Nothing's left over. Oh, remember, don't forget about that's a 1. Now let's see what we can do. 9 is a perfect square. 1 is a perfect square. So we can look at it like this, right? 3 squared is 9. G squared is g squared. And again, 1 squared is 1 squared. Be careful. This 3g outside stays outside. Okay? Stays out there. And what we have here, right, 3g plus 1 times 3g minus 1. So a little more difficult, but we're still using our knowledge of a plus b times a minus b. 3g plus 1, 3g minus 1. Let's look at a little more difficult one. Okay, this one I can see, 16, that's a perfect square. That's no problem. But what about this piece here? Remember, it's always a good idea to start by saying, okay, what thing squared? Something squared gives me b to the 4th. And hopefully you know that b squared squared, right? b squared squared gives me b to the 4th. So far this looks fantastic, right? That's b squared plus 4, b squared minus 4. And you might be tempted to leave it like this. But remember, this can be broken down into b plus 2 times b minus 2. So sometimes you have to really be careful about how to factor. All right, well, I hope that helps. Thanks for watching.